Lesson 8.5, Law of Sines and Law of Cosines. The objective here is to use the law of sines and the law of cosines to solve triangles. Remember that when we solve triangles, what we're really doing is filling in all of the angles we don't know and all of the side lengths that we don't know. You can use the altitude of a triangle to find a relationship between the triangle's side lengths. Remember that the altitude is the perpendicular line or segment that we've drawn from one vertex down to the opposite base. So h is our altitude. Okay. From the diagram, the sine of angle A. So angle A, sine is opposite over hypotenuse. Sine of A is h over b. Sine of b, looking this way, is h over a. By solving for h, we get that sine of a over little a is equal to sine of b over little b. This gives us the law of sines. If we use another altitude, such as if we dropped an altitude from vertex B down to AC, we would also have that sine of C over little c equals sine of A over little a and sine of B over little b. So you can use any of the three ratios. For any triangle, and this means even if it's not a 90-degree or right triangle, with side lengths A, B, and C, the sine of A, angle A, over the small length of A, its opposite side, equals sine of B over its opposite side length, which equals sine of C over its opposite length. And you can see that I've color-coded here. You can use the law of sines to solve a triangle if you are given the following information. Two angle measures and any side length, such as angle side angle or angle angle side, or two side lengths and a non-included angle like side side angle. Let's look at an example of how to use this. We're given triangle FGH, and we have two of the angles, so 39 degrees and 32 degrees, and we have GH is 40. If we want to find FG, which would be the top segment, we can set up the law of sines proportion so that sine of F over GH equals the sine of H over FG. Then we substitute in the values we were given. So the sine of 39 degrees over 40 equals the sine of 32 over FG, which is what we're trying to find. We use the cross products property, and we end up with FG times the sine of 39 equals 40 times the sine of 32. If we divide by the sine of 39 and put this into our calculator, we end up with FG is about 33.7 units. Let's look at another one. This time we're looking for the measure of an angle. So using the law of sines, the sine of angle P over QR equals the sine of Q over PR. If we substitute in the values we were given, we have the sine of 51 degrees over 8 is equal to the sine of Q over 6. If we multiply both sides by 6 so that we can isolate Q, we have the sine of Q equals 6 times the sine of 51 degrees over 8. We use the inverse sine function to find the measure of angle Q, because remember, the measure of angle Q is equal to the inverse sine of whatever the sine equals. So the measure of angle Q is equal to the inverse sine of, and then we put the whole thing in parentheses, 6 times the sine of 51 degrees over 8, which is about 36 degrees. The law of sines cannot be used to solve every triangle. If I am given side angle side, two sides with the included angle, or three side lengths and no angle measurements, I can't use the law of sines. But I can still solve the triangle with law of cosines. For any triangle ABC with side lengths ABC, little a squared, the side length squared, is equal to the sum of the other two side lengths squared minus 2 times the product of those two sides times the cosine of A. If you look closely at all three formulas for finding side lengths and the angle measurements, they all start and end with the same letter. The other two sides that are not the one you're looking for, or not the one that's on the other side, go together kind of like the Pythagorean theorem would. Okay? And then minus always 2 times their product times the cosine of the angle that goes with the side you're looking at. Same with B. It starts with B, it ends with B. With A and C, the other two sides together in the other spots. C and C at the end, with A and B in the other spots. If you can remember that you must square the other two, add them together, and then subtract 2 times each of those multiplied, their product, times that cosine, you've got the formula for any side you can put on the left-hand side of your equation. So let's look at an example. You can use the law of cosines to solve a triangle if you're given 2 side lengths and the included angle measure, or angle side, or 3 side lengths. An angle referenced in the law of cosines is across the equal sign from its corresponding side. So remember, it starts with the letter on one side, it ends with that cosine on the other. So let's use one and find xz. So we want to find this side length. We're given side, angle, and side. So we can't use law of sines. So xz squared will equal xy squared plus yz squared minus 2 times xy times yz times the cosine of y. And we use y and its opposite side because that's the angle we're given. Okay? So then we plug in the values that we know, and we have 35 squared plus 30 squared minus 2 times 35 times 30 cosine of 110. We simplify. Xz squared is approximately 2,843.2423, and then we take the square root. And most of this you'll do in your calculator. Xz is approximately 53.3. Let's look at another one where we're looking for an angle measurement. We've been given 3 sides, but no angles. But we want to find the measure of angle T. So on the left side of our equation, we'll be using RS, since that's the side across. Law of cosine says that RS squared equals RT squared plus ST squared minus 2 times RT times ST, cosine of T. We're going to substitute in the values we know. We have 7 squared equals 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of T. If we simplify this, we get that 49 equals 290 minus 286 cosine of T. Remember that when I'm subtracting here, I can't just subtract these two numbers. I'm multiplying negative 286 times the cosine of T, which I don't have a value for. So I subtract 290 from both sides, and I get negative 241 equals the negative 286 cosine of T. Let's go on. I'm going to solve for cosine of T by dividing by negative 286 on both sides. Cosine of t equals 241 over 286. You know that they're no longer negative because negative divided by negative does give you a positive. So now we will use the inverse function. We can't really use it until we get to the point where cosine of whatever angle we have is by itself. Then we use the inverse. Measure of angle t equals the inverse cosine of 241 over 286, or approximately 33 degrees. At this point, you could use the law of sines to finish solving your triangle if you were asked for all three angles. Do not round your answer until the final step of the computation. If a problem has multiple steps, store the calculated answers to each part in your calculator. Remember that you can use the second function and answer buttons on your calculator to then divide your answer by another number or multiply it by another number, or you can put it in the memory and recall. Let's look at a sailing application. A sailing club has planned a triangular race course, as shown in this diagram. How long is the leg of the race along BC? We want to find BC. How many degrees must competitors turn at point C and round these to the nearest tenth and nearest degree? So again, we're given side, angle, side, so we know we must use law of cosines. BC then equals AB squared plus AC squared minus 2AB times AC times the cosine of A, since it's across from angle A. We substitute in the values we were given. We have 3.9 squared plus 3.1 squared minus 2 times 3.9 times 3.1 times the cosine of 45 degrees. Because all of the values on the right-hand side are known, all we have to do is push this into our calculator. BC squared is approximately 7.7222. Then we take the square root, and we get that BC is approximately 2.8 miles. If you get a negative number for a square root, if you did it by hand, you would know that this could not be used, as our distance is never a negative amount. So you would take the positive square root of the number. Now we need to find the measure of the angle through which the competitors must turn. So measure of angle C. We use the law of sines now because we've solved the other side. So we have the sine of A over BC equals the sine of C over AB. Substitute the given values. Sine of 45 degrees over 2.7789 equals the sine of C over 3.9. Multiply both sides by 3.9, and the sine of C equals 3.9 sine of 45 over 2.7789. We're going to use the inverse sine function to find the measure, and it is approximately 83 degrees. Kind of a sharp turn if you think about that, for turning on the water to go on the course. Now you try. The first three are calculator problems where you're simply finding the ratios, and you'll note that they are negatives, 2 of them. Think about the coordinate plane system, where your x's and your y's are positive or negative, and you'll understand that since we have lengths, opposites, and adjacents, the adjacent is the side that represents x, what x is doing, and the opposite side represents y. So anywhere that x would be negative, so will your function. Anywhere that y would be negative, so would your function. But if they're both negative, you're dividing negative times negative, and so you're going to get a positive. So actually on this one, only one will be negative. Then find each measure and round to the nearest tenth and nearest degree for your angles. And then you're finding them again. I want you to have plenty of practice.